Hello! I'm delighted to have been invited to give the keynote at this conference. And I'm pre-recording this, so during my talk I think I'm available for questions, so I hope that you'll take the opportunity to do that. So I'm going to speak now about developer-tester collaboration. And I wanted to start by telling a story. Now this is about an organisation that I'm working with at the moment, and we've got the situation where we have separate teams. We have a system tester teams and a developer team, and the developers are developing step definitions, which is part of the automation needed for the system testers to automate some of the tests that they're doing. Not all the tests they do are automated, but the ones that they need the step definition developers to write some code. So the way it's worked for some years is that the system testers put a ticket in the ticketing system requesting a step definition. And that was working fine up until quite recently. But then they got a new product that they needed to start testing, and the requirements were a little bit different, and they needed a few more step definitions than they needed before. And what happened basically was that this ticketing system, everyone agreed that it had become a kind of bottleneck. You know, the system testers couldn't get enough requests through this ticketing system, and because the product was new, the step definition developers didn't really have all the background and didn't really understand the new system, and they didn't know quite what to write, and they had questions about the tickets, and things just really slowed down. So the first thing they did to try and fix this was that one of the testers, I'll call her Susan, started to try and get these requests through the ticketing system more easily. So she started coaching the system testers to write their tickets in a better way, include more relevant information so that the developers would know what to do. And she also quite carefully made sure that the right ones were at the top of the pile. She was prioritising them so that the work would get done in the time that they needed it done. But this kind of helped a bit, but Susan, she's a very skilled tester actually. Perhaps this isn't the best use of her time. Although coaching the other testers to write better descriptions of what they need, maybe that's good use of her time, but still, this didn't really solve the problem. So what happened then was that they actually gained a new team member in the system testers. They hired this guy called Michael, and although he was a tester, he had a background as a developer, and he knew a bit about writing these step definitions. So he kind of realised that he might be able to fix this bottleneck problem a bit. So he went to talk to the step definition developers and found out from them, how they write their code, what standards they use, where the code is. He got hold of the documentation, and he actually even got permission that he could start writing some step definitions himself. Once they got to know him a bit, they trusted him with commit rights in this repository. So what basically happened was that they now had a way to bypass the ticketing system. Michael could write the step definitions that he needed by talking to the developers, but also the other system testers could come to Michael and start to explain what they needed, and he was basically taking care of enough of the requests that the ticketing system was no longer such a problem, and Susan could step back into her normal kind of role, and ultimately the ticketing system stopped being this great big bottleneck. I mean, they were still submitting some requests that way. Michael wasn't handling everything. But this new arrangement, where they had this kind of bridge between the two teams, was actually solving the problem with a new product. And that's kind of where we are today with these teams. And I don't know how it's going to develop in the future. Maybe Michael will somehow merge with the step definitions team and bring all his knowledge about testing and the background of this new product and make them more effective. Or maybe the system testers will hire more people like Michael and gain that capability within their own team. Or maybe he'll just carry on being the bridge for some time. I don't know how this is going to play out. But I wanted to tell this story because I think this might be familiar to you as testers, that when you're working in a system testing team, somehow you need the expertise and things that the developers do. And there are different ways to achieve that. So I read this book recently It's called Team Topologies, and the authors are Matthew Skelton and Manuel Pace. And it's all about designing an organisation for fast flow, and when it's made up of teams, and that the teams have different areas of responsibility and different ways of working. And they're both from the DevOps community, and I think it's really relevant for us in the testing community because, of course, DevOps is all about increasing the collaboration between developers and operations people, and testing is an important part of both development and operations, and of course it needs to collaborate well with these groups. And so I think it's interesting to see what's coming out of this community. And one of the pictures in the book is this one. It's a picture of the communication pathways in an organisation that's made up of teams. And of course the widest and most frequent communication pathways are within the team. That's what you'd expect. They're the green high bandwidth communications within a team. But then between other teams, you talk to those people less frequently, so it's much lower bandwidth communication. And this is kind of normal that you have actually a limit as a person how many people you can talk to each day or each week or each month. And it's natural that you talk mostly with the people in your team. And what they've also pointed out, though, is that some of the time you need to collaborate more closely with one other team, and that point you might need a much higher bandwidth communication pathway with them, and that might only last for a period of time while you're solving a particular problem. And then perhaps you'll go back to a looser relationship again, or perhaps something else will happen. Perhaps those teams will merge, or you'll find some other way to manage that communication. So I would recommend looking at this book because it's all about, well, given these constraints that people have, that you can only talk to a certain number of people each day, how can we arrange our teams to make the flow of work most effective, the flow of features, the flow of value through our organisation? And they've identified these three main ways that two teams can work together. In the story I just told at the start, they were using this X as a service collaboration, where one team is just providing a service to the other team and they don't need to talk that much. Perhaps there's a ticketing system in between. And that works fine for some kinds of teams in some situations. But what happened with the story I told was that they moved more to this collaboration interaction, where there was actually a person, Michael, who was managing the collaboration. They tried first with Susan, but that didn't work so well. Actually, what they needed was a closer collaboration where they were actually doing work together. And that solved the problem that those two teams had at that time. The third way of collaborating didn't actually show up in that story. It's facilitation is kind of similar to collaboration, except that one of the teams is definitely helping the other one to achieve their task. So that's a different form of collaboration. But my point basically is I think that if you're in this situation that you're in a system test team or a test team that's separate from development teams, you're going to need to collaborate with those development teams, and there are different ways of arranging that. And if that's your reality, then perhaps there's some ideas in this book that would help you to make that collaboration more effective. So, having talked a little bit about being in a separate team from developers, most of the rest of what I'm going to say actually is about the situation where you're in the same team with other developers. And this is the situation that is quite common these days when it comes to agile development processes. This is a quote from the Scrum Guide, where it says that Scrum teams are self-organising and cross-functional, and cross-functional teams have all competencies needed to accomplish the work without depending on others who are not part of the team. So as testers, we really fit into that. We are needed, I think, to deliver software that's of good quality and has all the right features and fulfills the needs of its users. It's very good to have tester involved in this cross-functional team. So this is often the situation that we find ourselves in these days, where we're collaborating daily with developers, or at least communicating daily with developers, because they're on our team. And that's a situation where there's other ways of collaboration that we probably should be talking about. And I wanted to highlight something which I've been using a lot lately, which is called Ensemble programming. And originally it was called mob programming. Woody Zuhl wrote this book that I've got on the slide, and he discovered this way of working at an organisation a few years ago. And he named it mob programming, but I think actually I much prefer to call it ensemble programming because that name speaks to me a lot more about what it actually is. It's a friendly collaboration between a group that like each other and are playing well together, like in a musical ensemble. This mob thing is maybe a little more snappy, but I think it gives the wrong impression. So I call it ensemble programming, but it's the same thing. So what happens in an ensemble programming session is this is a picture of an ensemble I worked with a little while back. And you're all working together in a structured collaboration, the whole team, and you're going to produce software together. You've got one computer, that's the guy sitting at the front with the computer, who is controlling the mouse and the keyboard and entering the command, the software, the code, the testing, who's doing the stuff. And the rest of the team there is supporting that work. And the guy standing up there, he's taking the navigator role. So this way of working is structured, like I said, with different roles. And the typist, the person with the keyboard, is operating the computer, but they are not deciding what code should be written or what test should be done. That's the role of the whole ensemble, actually. But their spokesperson is the navigator. That's the person who's kind of leading the work. And they are speaking with words to the typist. I would like you to do this now. I would like you to write this code. I would like you to do this test. And you rotate these roles so that everyone in the ensemble gets to take their turn leading the group. And sometimes you might skip the typist role if you weren't so confident, or maybe you'd only take it in certain tasks, but generally the idea is that everyone in the ensemble will be able to step into any role. Now, I also mentioned this idea that you might have a coach or a facilitator for your ensemble. And that's particularly useful if you're just starting out with this way of working. Facilitating those discussions, making sure that everyone knows what their role is, and keeping track of time and when to rotate and stuff. But once you've basically got the idea of how this way of working should go, it can be useful still to have a coach who can then help you to learn new techniques or become even better at writing software together. So the first thing that people often say when they hear about this way of working, they think, well, this must be really unproductive or inefficient or something. But that's kind of missing the point. The real point with ensemble programming is you're trying to get the best out of everyone. As an individual, when you're working by yourself, you have good days, you have bad days. Maybe during the day, sometimes you're feeling a bit distracted or tired, and the code you write or the tests you do are maybe not the best. When you're working in an ensemble like this, you have the opportunity to get peer review and to be able to step back when you're not feeling at your best, and to collaborate so that the best gets into the code, so that everyone's best gets into the code. And the product that you produce together is of really high quality. And I've taken these pictures from another book about mob programming called the Mob Programming Guidebook. One of the effects of working this way is that everyone in the team understands the code, understands the tests that you've done, and has been a part of it and has contributed. So you have to collaborate. It's really a very intensive way of collaborating as a team. So that's got the advantage then that everyone feels ownership of the product that you've built together. But it's also a way to spread skills and knowledge within the team. So on this slide here, I've got a picture of a speech bubble. The navigator is saying something to the typist about Kubernetes and pods and stuff. The details are not important here, but basically I'm trying to show that the navigator is really expert with this. They know about Kubernetes and pods and stuff. And they're explaining what the typist should do, so that everyone in the ensemble hears what they should do, they see the code getting written, And then, of course, they have the opportunity to ask questions and to find out, well, why that file? Why that pod? And very soon, everyone in the ensemble has opportunity to learn this thing. And next time they have a similar task, then somebody else in the ensemble perhaps could take the navigator role and explain to the typist what to do. So it's a very effective way, in my experience, to spread knowledge and skills through the team. And I use this personally. This is because I want to spread knowledge about test-driven development and other agile coding practices. That's kind of my main job at the moment, actually, helping developers to learn to write better unit tests. And that I see as a really important part of raising the quality of the software. And I'm not, putting testers out of a job with this somehow. If the developers write good unit tests, that should mean that the testers have then much better opportunities to do more valuable work and more interesting kinds of testing and find those really high value issues that have blindsided the rest of the team. So I think writing good unit tests for the developers is a really useful thing. And I'm sitting there at the back as the coach or the facilitator, getting the ensemble running and then helping the developers with the unit testing. And quite often there is a tester on the team, and there is a tester who joins the ensemble. Not always. Sometimes they feel that their time could be better used doing something by themselves, but a lot of the time they do join the ensemble and contribute their expertise about, oh, we should write a unit test for this scenario, or oh, I think you've missed this case, or maybe they just keeping track of what goals you're working on, so that to inform them about what unit tests exist, so that when they test by themselves later, they know what's already covered. Quite often the tester actually skips the typist role and doesn't perhaps take the navigator role unless you're working actually on a testing task. But I still see a very valuable role for a tester in the team. So I had this slide, what does the tester do? And I've just explained some of the things they can do. And then in my experience, when I've been running ensembles, but then I found this article by Maarit Purjärvi, and she's explaining how she's been using ensemble programming and ensemble testing with her team. And she wrote this article explaining what she could do as a tester in this situation. And she described it as being like stealth testing. So when they're discussing requirements, she can be there and clarifying them just as they start to work on that requirement. Or as they're coding, she can notice problems and find bugs just as as they're being written. Or perhaps if the team is working on doing some testing of something they've just built, perhaps she could guide them into how to test that in different environments with different setups. She can suggest data and scenarios for that testing and ensure that the tests get automated and they get written. So, encouraging her team to spend time on those automation tasks. So that's a really interesting article. If you're interested in getting into ensemble programming or ensemble testing, there's lots of resources there I just mentioned. Okay, so now I'm actually going to change topic a little bit. I'm going to now talk about approval testing. And this is a technique that I use quite a bit for automation in testing. And because I'm imagining that many of you are not very familiar with this technique, I'm going to give you a bit of a demo. And that means I'm going to show you some code. And I'm just aware that some people in the audience maybe aren't so familiar with coding and code and stuff, and you might be a little bit worried at this point. But please bear with me. It's actually quite a short demo, and I'm going to try and explain what's going on. So I think you should be able to follow. Otherwise, you can ask me lots of questions afterwards. Okay, so what I'm going to show you now is a code kata. Now this is it's a word that basically means small coding exercise. This guy Dave Thomas got the word from his son's karate class. He thought that they practice in karate, so we should practice in coding too. So he came up with some exercises, code katas, and since then lots of other people have come up with them as well. And you can use them to learn coding techniques. And this is something I do quite a bit. This is a screenshot of my GitHub page, and I've just got loads of repositories which are starting points for these exercises. It's a teaching technique I use a lot when I'm teaching developers about test-driven development. But that's not my purpose today. I'm not teaching you test-driven development. I want to give you a demo of approval testing, and I'm going to take a code kata called leap years. So this is a very straightforward exercise that you can write with test-driven development. And I'm just using this because I'm trying to illustrate how things could work if you were using an approvals tool. So here I have my development environment, and on the left I've got just an empty unit test using ordinary JUnit, and on the right I've got a sketch. This is a picture of a whiteboard sketch that I made earlier. So I'm imagining that when we were coming up with the idea for this new feature, we would have had some kind of workshop or planning meeting where we'd have gone through the new functionality that we want, and at that meeting we'd have had business people and testers and developers present, and we would have sketched some concrete examples for this problem. And the problem that we're looking at here is leap years. Now, a leap year is one where February has 29 days. And it happens about every 4 years, but not quite every 4 years. So that's the rules that we've sketched here. 2001 was not a leap year, and 1996 was. And those are both examples of the typical case, whether they're divisible by 4 or not determines if they're a leap year or not. But then there's these two other examples illustrating the atypical cases. So 1900 was not a leap year, and that's because it was divisible by 100. Whereas 2000 was a leap year, you might remember, and that's because even though it's divisible by 100, it's divisible by 400. So that's the rules, basically. I didn't make them, but I'm in this code kata, I'm going to write some code that's going to write a function that's going to do this calculation and decide whether a year is a leap year or not, and return true or false. So I'm starting from this sketch of 4 examples and 3 rules. So I've got this sketch kind of in my IDE so I can refer to it when I'm writing my code. And I'm going to keep it there on the side while I'm coding. So here we are, I've got a unit test here, as I said, and I'm going to start writing this unit test code by just making a list of my 4 years, my 4 examples. I'm putting them in a list. And that's because I think this is going to mean I can write all 4 of these examples basically in the same test. It's going to be a bit easier to read and understand. So there's my list of years, and then I need to do something with my approval testing. So here what I've got is this library approvals, and this is Java, and you see that the IDE has just kind of got the import there. It's org.approvaltests.approvals, and this library is available in Java, it's available in C#, it's available in all sorts of other languages. And I should also point out that this is not the only approval testing tool out there. There are others that use the same approach, but this one I felt was quite convenient for demoing to you today. So I'm using the verify all method in the approvals tool, and I've chosen the verify all because it works with lists, and I've got this list of test data I want to work with. But the first argument to the verify all method here is a header. I can write anything here actually, any kind of text that I want to appear in my approved file, as you'll see in a minute. So here actually I'm going to write these 3 rules that we identified that are in our sketch. So I'm going to write them on 3 different lines with new lines so that it's really easy to read when it comes out later. So there we are. I've written my rules, but my code doesn't compile yet because I need a couple more arguments to this verify all method. This went a bit fast there. The years, that's my list of test data of 4 years. That's the second argument. And then the third argument here is a printer. And believe it or not, that is the Java syntax for a printer function. And the printer function, I'm going to ask IntelliJ to just create it for me, and then I just need to tell it a little bit more about what kind of a function this is, because it's very specific. When you write a printer here, it's got to return a string, the printout, And the argument here is an integer because my list is of integers. So whatever type your list is of, that's the type here you need to pass this function. So at a basic level, to get this to compile, the easiest thing to do is just to turn the input data into a string. And that is just enough code that I can now, I've written an approval test and I can run it. But it's not actually testing anything yet, really, nothing very interesting at least. But it's a start, and I can actually now run this. So when I run this, it fails. And you can see there my IDE has reported me. I've got this failing test, and that's actually completely normal. For an approval test, it pretty much fails the first time. And that is because of the way approvals works. So if I just show you now what's happened when I ran this test, here I've opened up the Project Explorer on the left, and I've got the leap year test, that's the code I was just working on, highlighted. And just below that you can see I've got this new file written in red, and it's called leapyeartest.leapyear.received.txt. And that file was just created just now when I ran that test, because what happened was the JUnit ran the test and it got to the approvals.verifyAll, and it ran my printer on my list, and it came up with some outputs, and then it looked for an approved file that it could compare it with, and there wasn't one. So it wrote what it got to this received file and failed the test. So now if I look in this received file, you can see this is what my printer has produced. It's those rules that I've written in the code, and then the 4 pieces of test data that I printed out in the printer. So this is starting to look a little bit like my sketch. So here I've got them both on the screen together. And that's basically the idea. I'm trying to get my approval test to produce a text that looks like my sketch that I can use as my test. So I've got a bit more work to do, but this is I think I need to get this thing to actually also print out some results. Not just the input data, but also the result. Oh, and I've missed that 4 in the rules. I'll just fix that. So I ran the test again there, and it's still failing because I still haven't got an approved file. But at least now I've got all the rules written out correctly. And now I'm going to actually fix this thing so it starts to print out some kind of verdict about whether this is a leap year or not. So for the moment, just the simplest thing I could think of was just to hard code it to write false. So now when I run the test again, it's going to look perhaps a little bit more like my sketch, except that all of the results are false instead of some of them being true. And that's because I haven't implemented my leap year function yet. My functionality doesn't exist. But at this point I can examine how good is my printer, how similar is this to my sketch. When I've implemented this function, is it going to look right? And that actually, I'm beginning to like the look of this and think that it's actually might be worth keeping. So I'm going to approve this. So I don't know if you notice, I just asked my IDE to rename this file. And so I'm going it brings up the name, it's called leap year test, leap year received.txt. And I just replaced that received with approved. And for this particular approval testing tool, that is enough to indicate that I have approved this output. That this is the gold standard that it should judge any future test runs against at this point. So now when I run the test, it passes. And that's because the received text exactly matches the approved text. Now, some of you, I'm sure, are thinking, that test is passing, but she hasn't written the code yet. It's wrong. She's approved something that's wrong. I have indeed approved something that is wrong for some value of wrong, but it's similar enough to what I want that this is a good checkpoint. And the advantage now of the test being green is that I can actually start to work on my production code and via a refactoring. So when it's green at this point, I can start to write in, that's a call to my actual production code, my leap year util class. You know, has to be a class, this is Java. So I'm just going to use my IDE to help me to create this leap year util and the stub of the function. And initially I'm just going to have it return false, exactly the same as my previously hard-coded false, which means when I run the test, it passes. The output is still the same as it was before. That proves to me this was a successful refactoring, and now I've actually got some production code I can start working with and actually implementing this leap year determining function. So I clearly need that false there to turn into a true. So now I can go and write some production code to implement the first rule. That was it. I told you this was actually quite a simple example, but the amount of production code I'm writing here is not representative of a real system. Of course, I'd write a lot more in order to get the first scenario or rule to work. But now I've got my test to fail. The output has changed. So I'm getting true in some cases now. And if you look at this, I've got it set up with a window. So you can see my sketch is still there on one side. And on the other side, I've got the approved file that I had from before. And in the middle, I've got the new received file. And so that's the up-to-date information about what my program is doing now. And it's doing something different than what I approved, but it is actually more similar to my sketch than what my approved file is. So this could be worth approving. So I'm going to do that using the diff merge tool. It's got that little button in the middle to synchronize the two sides. So now my approved file and my received file are the same. And when I run the test again, it passes and the tool just removes the received file because it doesn't need it anymore. So that's good progress. But I've still got some work to do because I'm not handling the other two rules yet. So let's put in some code to handle the rule with the 100. And then again, my test fails and I can check out the diff and see, yes, I'm getting there. But I've still got one case that's not quite working yet. But still, this is an improvement. I'm going to approve that again. And now my test is passing again. At this point, I could refactor if I needed to, but I don't need to refactor at the moment. I'm just going to press on and implement that last rule here in my code. So I'm going to put in that rule about 400, and that should be enough that now when I look at my received file, it's pretty much the same as my sketch. I've got the true false thing looking correct, so I'm going to approve that. And that means that now I have a passing approval test that hopefully shows that I've implemented the whole code kata. So I'm just taking another last look at my sketch next to my approved file so I can just see, did I miss anything? Have I got all the information down? Is it as readable as my sketch? I think this is okay. So at this point I can actually delete my sketch and I can actually check in this code and this test as part of my test suite. And here I've just arranged my windows so you can see my approved file on the right with all the scenarios and the rules, and on the left I've got the automation code that's needed to make that test actually execute. Right, so I just showed you a demo of how to use approvals to test the code for the leap years kata. And if this is the first time you've seen approvals, I'm particularly interested in what your opinion of it is. And since this is pre-recorded, it gives me the opportunity now to say that if you want to go and write some questions in the chat, or think of what you really like to know about approval testing, or just comment what you thought of this approach. Does it look hopeful? Is this something you could use? What questions do you still have about it? And that means that in the session I can interactively look at your comments and perhaps give you some answers or something. So now is a good time to take a few minutes to actually go and write something. Okay. I'm going to go through a little bit more about the theory of approval testing now. You've seen the demo, so you've seen it in action. And you'll notice that I was using an ordinary unit test actually for the automation part. And a unit test normally has three parts: arrange, act, assert, or given, when, then. And the approval testing is primarily changing actually the third part here. Instead of writing assertions, you're comparing against approved outputs. And if there's no approved outputs, then the test fails. And if there is approved output, then it will take whatever is received from the ACT step and do a diff against the approved output. So that's the biggest difference with a normal unit test or another kind of test, is the assertion is different. But there's an additional part here that you also need to print the outputs from the ACT step in such a way that it's suitable to be compared in the approved or the verdict part of the test, where you're trying to determine if it passed or failed. And any old text is not necessarily the right thing. You want some text that's printed out that's going to express the scenario that you're trying to test, and is going to be readable, and is going to contain the right level of detail to check that the right things happened. So designing this printer is actually a really important skill for approval testing. And you want this property that it can be read and reviewed by non-programmers, because you typically would be using approval testing, or you could use approval testing as part of a behaviour-driven development process, where you have this workshop and you discuss scenarios and examples and rules with stakeholders and testers and people, and you turn this sketch that you come up with at that workshop into the approved file that becomes your regression test. So this leap years example here is there's no user interface, it's just a function, it's just a back-end function, and it's quite a simple one at that. So this code kata doesn't really show you the full power of this approach. So I've got an example from my own experience where we did this. We used approval testing on this crew planning application, and this is a rich client application, and here we're planning 3 crew members of aeroplane crew, and they're flying about between Oslo and Copenhagen and places, and you can see the 3 crew members and their schedules basically. And we were testing this to check that when you did stuff to manipulate the schedules, then it would update correctly on the screen. So it was very important that the lines and boxes here were displayed correctly. So what we did was we wrote a printer that would, instead of using this GUI directly in the approval test as a visual diff, we designed a printer that was going to print that out in ASCII. So it would look like this. So this is the same screenshot, only in ASCII, and you can see you've got the 3 crew members and their schedules, and instead of actually being blue boxes and brown boxes, it just says brown or blue, and then it's got some kind of dashes and lines and stuff. So this was the appropriate level of detail for us to check that this application was working correctly. I've got another example here. This is a cloud invoice service that I also worked on, and this was all about invoices. So this one's in Swedish. Apologise for it not being comprehensible, but one of these is a PDF of an invoice, and the other is the printed rendering of that PDF. And as you can see, it contains all the same text, and it's kind of laid out roughly, but all the details of the styling and the fonts and stuff has gone, because actually I don't really mind if those things change. I'm really interested in the content of this PDF. So in this case, I was able to use a utility as my printer, as a Python program called PDF to text that just does this. So in both of these examples, I've shown that I'm using a plain text printout of the thing I'm interested in checking, and not the original thing. And that has a number of advantages. I mean, you can use approval testing with screenshots and with PDFs and diffing them directly. But the advantage of using this technique with the printer and then the ASCII is that plain text ASCII is easy to diff, it's easy to version control, it's easy to bulk update. If you've got a lot of tests that are very similar, that have the same screenshot in them, and then something changes on that screen, some text or other, you can kind of do a global search and replace, and then suddenly your tests are passing again. But perhaps even more importantly than all of those things, it gives you the control over the detail that you're checking. It gives you direct control over that. You can choose when you design your printer, what is the level of detail I want to actually check and approve against, and what are the things here that are just styling or details that they could change and I don't want my test to fail, actually. So that's a little bit more background about the kind of approval testing that I'm talking about here. And I want to bring this back to talking about collaboration between developers and testers. And I want to talk about behaviour-driven development, because behaviour-driven development is an approach to agile requirements and teamwork. And I think it's a very useful method to use in a team where you're collaborating in an agile way with developers and testers and business stakeholders and business analysts and so on. So I recommend this book by Gaspar Nagy and Sebastian Rose. In fact, they've written 2 books and there's a 3rd one coming about the process of behaviour-driven development. So this is a picture from their book about the way the BDD works is that you start with trying to discover what it is you're trying to build in this software development team. Can we build a shared understanding through collaboration and structured conversations? And that arguably is the most important part of this. But once you've had those conversations and you've got these examples, you can then formulate them and document these scenarios as something that then could be automated as a test, as a regression test. And this allows you to then verify against the running system that the examples you came up with in discovery actually are valid for that system and the thing is all working properly and your understanding of the system and how it works is correct. So this BDD process starts with discovering examples, discovering and having conversations about concrete examples and rules and what the software should do. And this typically would involve several job roles coming together and collaborating, some kind of workshop or meeting, with a tester and the developer and somebody who understands the business and what the business is trying to achieve with this software. Would be like the minimum set of people you'd invite. You might obviously invite others as well who might have more interesting perspectives. But the outcome of this then is some concrete examples or a sketch of what the software should do. This was the starting point in the demo I gave of approval testing with the leap years, that sketch of the rules and the examples. So if this was that crew planning software that I mentioned earlier, perhaps what we'd be doing in the workshop is looking at a screenshot from one of our existing tests and talking about, well, for this new feature that we want to build now, we need a new button here, and we need this text box to be over there, and perhaps we'd be working with actual screenshots or with the application and discussing concrete examples and rules for how it should behave and noting them down in sketches like this or perhaps on in a similar way to you would just on paper, So after this discussion then, the next part of BDD was then to formulate that into something that you could then automate as a test. And this part, typically, you get together the tester and the developer. And those other job roles that might have been present at the first meeting are perhaps less interested in this part. It's really about the developer and the tester agreeing what is important about this scenario to actually check, what are the details that we need to include in the scenario that the business person can read, and what are the details we need to check at the automation layer later on. So in approval testing, you'll be discussing the printer, basically. You'll be discussing what this part should look like. What are the details that we want here? And this is where you're talking about the details of the scenario. And this is where I really see approval testing needs a really strong collaboration between these two job roles. The tester has a very good sense of which scenarios are important, what details are important, and the developer has a very good sense of what's going to be easy to print out and what's possible to print out and how we're going to do the automation later on. So this collaboration is pretty important for this approach to work. So when you've got the test basically sketched and formulated, and then you have the part where you actually build the software that should do the stuff, and then you need to review when the software is built. And you do this review together with the the original business people, hopefully, and you need to perhaps demo the new features and demo the way the automated tests check the new features, and perhaps at that point you would bring up the actual printout and show it to the business representative and say, this is what we're actually checking in our tests. In my experience, the business people actually aren't very interested in that. And they mostly just want to see a demo of the working software and trust that the developer and the tester together have come up with regression tests that are going to keep the system running. So actually, that's what I expect to happen, really, that the tester and the developer are discussing how good the regression tests are now the feature is built. So we're coming towards the end of my talk now. I just have this final slide where I want to give a summary of all the topics we brought up and remind you what I've said so that you can remember it. So we started at the beginning. I told this story about these two different teams. You had a separate tester and developer team and how they changed the way they interacted with each other. And I was able to model that with this model from the Team Topologies book, and explain that this would be a normal way of the organisation evolving. Then we've got the perhaps more usual situation that I work with, where you have testers and developers in the same cross-functional team, and you're working with agile methods and you're talking daily or weekly and discussing how to test and what to build and we talked then about this technique called Ensemble programming, Ensemble testing, and how you as a tester can get involved in that. And perhaps you could suggest your team should do some of this, maybe not all day, every day, but this is something that you could do and try out and work out if this is an effective way for your team to work together, and whether you as a tester can really make a good contribution here. Then we shifted mode a little bit and talked more about what approval testing is, and I showed you a demo of that. And I talked then a little more about the role of the printer in this, and how I see that this approval testing technique really works very well when you can get developers and testers to collaborate over these printouts and these examples and this automation. And the tester then is an important input for the automation, even if they don't do it themselves. So the developer probably is doing the automation, but the tester really needs to give their input about the printer. Great. Thank you so much for having me with you today. I hope you've found something in this talk that's going to help you and inspire you to improve the collaboration in your organisation between developers and testers. Thank you.